bot should hopefully pick it up as well, shouldn't it, at some point?
Yeah, Facebook is live, YouTube is live now.
Lovely. Okay. Oh, there we go, and the bot has picked it up. Wonderful.
I do like that little bot.
It is really handy. Okay. Well, we'll let everybody join in, and then we'll make a start. For those of you who are here already, welcome. If you're watching us on any of the other streaming platforms, hope everybody is well. We'll just give everybody a little bit of time to join in. Hello, Liz. Welcome. Just give everybody a little bit of time to join in, and then I'll start going through what we're going to do today and what our plans are for TechnoCamp's Coding Club. There we go. Okay. Yeah, so I'll just give everybody a couple of minutes to get settled in, and then we'll get started in a minute. How's everybody doing? If there's anybody there, feel free to post in the Discord. Okay. I can see that there are some GIFs starting to appear in the in the chat. Yeah, so we'll make it start about 5 past-ish, just to give everybody a chance to join up and things, since we have been off for a few weeks now, so we can get back into the swing of things. Okay. While we're doing that, I'll just grab the first link for today. Bear with me. Get that popped up in Discord in a second. Wow. At least you made it, Chris. That's pretty good. Okay, so while everybody's joining, I'll just pop the link to what we're going to do to start with today in the Discord. So the plan is, I thought today, you know, it's the last week before before we get back into school and stuff. So I thought, you know, what we'll do today is we'll have a bit of a relaxed sort of session, and we'll sort of chill out for a little bit, so that we can have a bit of fun before we get back into before school starts again. So the plan for today is we're going to play a little bit of a game to start off with, done by BBC's Doctor Who. So we're going to be messing about with a microbit to rebuild, rewire, and recode a Dalek. Okay, so it's going to be a bit of a different kind of activity to what we're used to. And then once we've done that, we're then going to move on to actually programming a microbit, but we're going to be doing it in Python. So that's what we're going to do. That's what we're going to do today. So I'm just going to post the link to the Doctor Who page in the Discord, and what I'll do is I'll start the stream up on Discord as well, just so that you can see my screen on here as well. So I'll just do entire screen. There we are. So in case you want to have a look on Discord, it's now on there too. Okay, so the plan is to essentially just work your way through the activities that we have in the Dalek Hack website. Okay, work your way through them and start off with block-based programming. And if you fly through it, which I'm sure a lot of you will, because you're already all pretty good with this sort of thing. So if you get through it quite quickly, try and run through the activities again, but do it using Python. Or if you want to, you could even do it using JavaScript, okay? So start working your way through the activities that we've got in there, and I'll be going along with you so that I can help out in case any of you get stuck. So we'll spend a little bit of time doing that. We'll spend maybe the first 45 minutes of the session working through the Doctor Who game. And then once we've gone through the Doctor Who game, we'll then move on to using virtual microbit, because of course, and if you have got, by the way, I'll add now, if you have actually got a microbit at home, feel free to kind of make use of it. Okay, I'm not sure if any of you have got any microbits, but if you have got a microbit at home, definitely make use of it in today's session. But if you don't, we will be using the virtual microbit anyway. So the activity that I've chosen for us to do using make code is suitable to program a virtual microbit. Okay, so you don't have to worry about having that physical microbit if you haven't got one. But if you have got one, feel free to use it. Whilst everybody's just joining and we're starting to load up into things, I'll just give a bit of a run through as to our sort of plans for the next few weeks and things. So it's me and Joe on the stream today. Okay. So if you have got any questions, remember to post them in the Discord, and we'll do our best to answer for you. Our plan. So as you know, we've had a couple of weeks off now for Summer of STEM. So for those of you who joined in with that, I hope you all enjoyed it. I certainly did. I had a great time. Got to meet lots of different people, got to participate in so many different sessions, and I had a really great time. So hopefully for those of you who did join in, I hope you enjoyed. So as you know, we've had a couple of weeks off from the Coding Club now as a means of, allowing the Summer of STEM activities to take place, but we are, of course, now back. So our plan currently is to continue to run the Coding Club sessions for the foreseeable future. Okay, so we're going to try and keep running these weekly. Of course, if there are any sort of changes to the schedule, or if there are weeks where we're not going to be hosting a session, we will let you know. But our intention is to try and keep these going every week. So hopefully we should have sort of different things happening every week at the same time on a Wednesday. Okay, normally it'll be between, like I said, 4 and 6. Okay, like we have been doing, but just that's the plan currently. What we would like to know from you, and this is the reason why I'm kind of starting the session off with this, is there anything in particular that you would like us to focus on in the coming weeks? Okay, now obviously you don't have to answer straight away. If you would rather have you can have some time to think. You don't even have to answer during the live stream. Okay, you can just answer during the week, because I'm always monitoring the Discord anyway. So if you do want to have a look, if there's anything in particular that you would like us to focus on, then let us know. I can see that Alex JavaScript wants to focus on Unity. Okay, so I'll be making a note essentially of everything that you recommend, that you suggest that you would like to cover. We'll see if we can develop anything around that. We might not be able to get everything sort of fitted in. Okay, so it might be a case of us looking at things, doing different things at different times, but if there are things that you think of during the week, or as we're going along, let us know, and we'll try our best to kind of fit those into sessions. Okay, we'll see if we can find different things to cover, because of course these sessions are for you. So if there's anything that you would like us to do, then let us know. Okay, super. So, I think that's pretty much all of the housekeeping jobs covered. Everything that I needed to discuss, I think, has been mentioned. So, we're going to start off now with the Dalek Cactus that we've got covered today. So, I'm going to make a start on here. Like I said, feel free to follow along with me, going off in your own time, and during the session, you don't have to stick to where I'm up to. If you'd like to go ahead, then feel free to do so. But I thought, we'll start off today with a little bit of fun and play a bit of a game. The main purpose of this game really is to teach you a little bit more about block-based programming, or Python, or JavaScript, if that's what you'd like to focus on. I'll be doing it block-based today, though, and it helps you kind of build up an algorithm. So for those of you who might remember, as we've discussed in the past, we have this idea of an algorithm, which is a sequence of instructions that we're using to, or that we use to program our computers and things, as our computers need to know what to do. Okay, they're very, very good and they're very clever and they can do a lot of things, but they need to know what to do and in a way how to do it. Okay, so we build up this algorithm, we build up this sequence of instructions, and that's of course what we have in this. So I'm going to make a start. If, like I said, you do go ahead and you finish this and you finish the game using block-based programming, then try out Python or JavaScript or something like that, so that you can see how you fare with that. Because, like I said, during the second part of today's coding club, we're going to be looking more at Python. So that's what we're going to do. So I'm going to make a start on here. So as I said, today is about a bit of fun. And I'm going to just talk us through things as we're working through them. So I've got to currently decide what colour Dalek I'm going to have, and I think I'm going to have an orange colour because I like orange, and maybe a red. There we go. So that's what I'm going to go for. Okay. So start working your way through it. It is quite sort of self-explanatory in terms of what you need to do. It's mainly about getting you thinking about that idea of an algorithm. So I'm going to start things off here. So feel free to post screenshots, ask questions as normal in the chat. If you get stuck, if you need help, just let us know. We'll do our best to help you out. So get this microbit programmed up. So you can see the idea, for those of you who can see my screen now, who are watching the stream, is that essentially what we do is we program the microbit using these cables. Okay, so how we attach them to all of the different things that run along the bottom of the microbit, all of the connection points. And each one of the things that we're connecting to the microbit allows the Dalek to do different things to navigate through the maze. And then you can see that on the second screen, once you get to the recoding screen, you can then choose the language in which you're programming in. So you can do it in Python, you can do it in JavaScript if you want to try one of those two languages out. Like I said, to start off with, say I'm going to go with block-based programming. And the objective is to always try and get to the end, essentially, of the maze. Okay, that's the general objective. But what you need to do is think about that idea of an algorithm and the most efficient way of building your code. Because, of course, as we remember, there can be lots and lots of different ways of doing something. But what we need to try and do is find the most efficient way of doing it. So that's essentially what we've got, the strategy. Okay. So for this, like I said, I'm going to talk through this first activity. If you want to go ahead, that's absolutely fine. But I'm going to talk through this first one. So we need to get the Dalek from the end of the maze here to the green cable, okay, which is going to power one of the Dalek's control features. And you can see that we're using a loop. And of course, the idea of a loop is that it repeats a bit of code over and over and over again until a certain number of times that you specify, or until it's told to stop. Okay, if it's an infinite loop, it will just keep going until it's told to stop. So what we need to tell the microbit in a way is what part of the Dalek needs to be controlled. So that's what these two flashing question marks are here. And of course, what we need to do is have it control the motor, because the motor is what's going to drive that Dalek to the green cable. And now we need to tell it what direction to go. So you can see that there are lots of different directions. So you could kind of picture this a little bit like how we were programming the agent in Minecraft. Okay, so remember how we were programming the agent to move in different directions, to drop things, to pick up things, to place things, to build things, that sort of thing. It's kind of it's similar in concept. Okay, so we're going to say move forwards, and then of course it's asking how many times. So of course here we know it gives us the hint that it needs to be 4 times. So we're going to repeat 4 times, and once we've done that, we hit run code, and then you can see now that the Dalek is following the instructions that you gave. So we've now picked up, of course, the blaster wire, okay, and we now need to try and complete the maze again. Okay, now it gives you a lot of hints in terms of what you need to do here, okay. It already gives you the blocks. What you need to do is work out what sequence those blocks sort of need to run in and what you need to run and when. So I'm going to go back to the rewire section, and I'm going to start working through this now as well. Out of interest, have any of you watched Doctor Who? Are any of you fans of Doctor Who? I know I am. You are, Chris. That's cool. Do you have a favourite villain in Doctor Who? The Master. That's pretty cool. Yeah, he's pretty evil. I think the scariest villain, in my opinion, is definitely the Weeping Angels. I'd say. I think they're definitely the scariest villain in Doctor Who. Yeah, they are pretty terrifying. I know, Rory and Amy, I couldn't believe it. But just when you thought they got away as well, and then one had to just pop up, and I know, terrible. But it was still a really good sort of end. I know it wasn't the end of the series, but it was still a pretty intense end to the episode. Right, so we're here, so got to move the Dalek along. So we're going to, of course, be moving. As you can see, what we have here is this idea of nested loops. So we've got a loop inside of a loop. Okay, so that means that everything that's inside of the big loop is going to run the amount of time specified. So in this instance, of course, 2 times. Okay, and then everything inside of that loop is now going to run twice. So we need to have the Dalek move forward 1, 2, 3, 4 times. So we're going to have it move forward 4 times, motor send forwards. Then we'd like the Dalek to turn right. So we'll say Dalek turn right. Then we want the blaster to go off. So blaster will blast. That will clear the path, and then it will continue forward then to pick up the next wire. Okay, so that is the solution. If you haven't got it already, I'm sure a lot of you probably already have, but that's the solution for this first one. So we're going to go forward 4 times, turn right, blast that crate or that box, and then continue through to the end of the code. So if I run the code, let's see if it works. So you can see that that bit of code there, I know a lot of it is of course already given to us, but it is very efficient in terms of what it's doing. Okay, it's very kind of well structured. Okay, it follows the solution well, and it works really quite easily. So that's a nice solution. So now we've got another wire, so we've got to try and program this part. Now, if I remember correctly, I spent quite a lot of time trying to figure out what I needed to do on this one. It was either this one or if there's another. I thought actually it might have been the next one. It took me a long time to try and work out what I actually needed to do. So let's see how quickly. I'm sure a lot of you will fly through it much faster than I will. So let's see. So we've got two separate paths here. So we've got to try and think what the. Again, in this case, one thing that you could do here, if this was a slightly kind of different layout, is you could look at what the most efficient way of getting to the end would be, because sometimes there are multiple different ways of reaching the end. However, in this case, I think it's just as efficient in either direction, really, so it's up to you. So let's have a look. So we're going to be repeating 2 times, and then once that loop is finished, we're going to repeat 2 times again. Okay, so I'm going to move the motor forward, I think. Then I'm going to go to the left, and then I'm going to move forward again. You just beat that level, Alex. Well done. Oh, actually, that's wrong. You need to turn to the right. Oh no, forwards. There we go. So if you do get stuck on the level, you could try out pseudocode for a bit. So you could try actually writing out what you need your Dalek to do. So that way, what you can do is you could write out on a bit of scrap paper what path you need the Dalek to follow, and then once he makes it sort of part way through, you could then try and figure it out that way. So let's see. So he goes forward. He's turning left, and then he's going forward. So I now need him to, no, so that's going to repeat twice, isn't it? So that's not right either. So forward, left. Let's have a think. So he's going forward here, and then he's going to turn left, and then he's going to go forward. But that's no good. Ah, yes. Now I see what you mean. There is a move option rather than a turn option. I see what you mean. Good point. Good point. So we're going to go forward, we're going to move left, and then we're going to do the blast. There we go. Not the blast, the manipulator. Activate. There we go. Yeah, I can see what you mean now. So I was just making the same mistake as what you said then, Alex, about the move option. So move forward, move left, activate. Okay. So he's going to do that twice. So he's going to go duh, 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 and then he's going to go duh, duh, duh. So then I need him to move right and then move forward. So I need him to go motor. Doctor Who gifs, yeah, are pretty cool. Move right. Then we will have the blaster. And then move forwards again, I guess. So motor forwards. Right, let's see if that works. Okay, so far so good. Oh, okay, so I have made a small error, as you can see. So let's try again. So he's going forwards, he's going to the left, he's going forwards, he's going to the left. So what I need to do is have him go forwards first, then move to the right, and then do the blaster. So it's all about trial and error, really, okay? It's all about trial and error. You know, sometimes you'll try something and it won't work. Oh, I've clicked the wrong one now. It's meant to be move right, not turn right. There we go. There we go. This is looking promising. There we go. So there we are. Oh, I've only got 2 stars for that one because I made a mistake. Okay, so this one you can see starts to incorporate this idea of a while loop and if and else if and else statements. Okay, so you might a lot of you might remember what these are. So I've just got a iStalk. I need to include the iStalk. It says now. So we shall remove the manipulator because we don't need that for this one, and I shall add in the iStalk. You can see a Weeping Angels GIF has just been added. And if I remember rightly, that is from the episode where they're all underground, right? And there's like a big forest full of them, if I'm remembering rightly. Pretty sure that's what happens in that episode. That one's pretty scary. Yeah. Jodie Whittaker is agreeing. Okay. So as I mentioned, what we've got here is this idea of a while loop, and we've got if statements, else ifs, and else statements. So of course, a while loop is slightly different. So what we were using previously, you could say, was the equivalent of a for loop. So what was happening was we were specifying exactly how many times we wanted that loop to run. So that's the equivalent in something like Python of a for loop. So we're saying we want the loop to run this many times, and the loop runs that many times. Okay. The while loop is slightly different because you can see that the while loop has got a condition attached to it. So the while loop is saying while Dalek not home. So essentially, that in this instance is the equivalent of saying while true. Okay, so we're saying while true, so while the condition is true, we want the loop to keep running. So the loop will keep running until that condition becomes false. And that same concept is applied here with the if statements. So we've got an if statement, we have an else if statement, and we have an else statement. So what's going to happen is it's going to say, right, if blah-de-blah is true, then do this. Else if blah-de-blah is true, do this. And if neither of those conditions are true, then it's just going to default down to the else here, and it's going to then run that bit of code. Okay, so that's the concept. So let's have a go at this one. So if, okay, so what we're going to say here. So if iStalk is empty, then I'm going to have the Dalek move forward. Okay, and then we're going to say else if the iStalk. Oh no, we don't want that. No, actually, we'll say else. So what we want is, so if the iStalk is empty, we want it to move forwards. Otherwise, if we come into contact with a crate, then we want the blaster to blast. Otherwise, we want the motor to go to the right, I would say. Turn right. So turning right this time. Let's see if that works. So it's checking if the iStalk is empty, which it is, so that's fine. It's running through each one of those conditions in turn. So there we go, he's turned right. It's realised now there's a crate in the iStalk, so it's moving forwards. It's realising, okay, there's no crate, it's not empty, there's a wall, so it's turning right. It's blasted away the crate. So you can see that the blue, those flashing dots that appear when you're running your code, you can see there that what it's doing is it's checking each one of the conditions of the if statement, seeing which one is true, and then executing the code that comes beneath that condition. So you can see now that it's checking, okay, the iStalk's empty. The iStalk has now got no crate in front of it, it's not empty, so it's turning to the right because that's the only other thing it can do. It's proceeding forward, it's going forward, turning again. There you go. So you can see now that it's checking each one of those conditions in turn, and then it gets to the end. Okay, so now we found a voice wire. So that's pretty cool. And so that's the idea there with the if statement. So you can see now that things get a little bit more complicated, and this is the one that I think that I found the most tricky, because there was quite a lot of different strategies, and it took me a while to figure it out. So hopefully I can figure it out again today. First thing I'm going to do is just rewire. So we don't need the blaster this time, so I'm going to pull the blaster out and I'm going to put the voice in. So now we've programmed the microbit, and now I'm going to try and figure out what we're going to do here. So we need to get the Dalek to reach the end of the maze. Okay. So how are we going to do this? So suppose if the Dalek has got nothing in front of the eye stalk, then he's got to move empty. Then we want the Dalek to move forward, so we're going to send that motor forwards. Okay, super. So we're off to a good start, I think. Now, of course, what we need to do is check if there's a Dalek in front of him, and if there is, we need to tell that Dalek to basically move. So, so you can see that what we have here within the else if, the second if statement there, is there's actually a nested if statement. So we're going to be saying if there is a bit of code, so if the first condition isn't true, default to the else. However, if we're defaulting down to this else, we are also then checking another condition when we're running that else segment, and we're checking if a certain other condition is true, and if that condition is true, then we're going to send the Dalek, well, we're going to do something with the Dalek. Okay. So, and then of course at the end then he's going to reach the console and he's going to send an eject. So, we're going to keep moving forwards, and then we need to know if we reach a Dalek what we're going to do. So if, let's just try this, so if there's a Dalek, then we want the voice to say, we'll go with I am a Dalek. There we go. Okay. Okay. Now, of course, we need to get them to turn as well. So we could try, let me try something. We could say, what could we do here? So it's going to go along there, Dalek's going to go back, then Dalek's going to move to the right. So either he can move to the right, check if there's a wall. So let's just try something. Yeah, let's just try something. So we could say now if he gets to the wall, he's going to move to the right, and then if the eye stalk has got a wall, then he can send the motor to turn around. Now this might not work, I'm just trying this out. I can see that we've got some GIFs in the Discord now of Strax and also Matt Smith wearing a fez. Fezes are cool. Yes. Although I have never worn a fez. Okay. Let's see if this works. Okay, so not ideal so far. Dalek has moved. Okay. Turn around. Okay. So off to a good start. But now there's going to be a problem. Because you can see now that he's moving to the right, there's a wall, and he's just going to keep turning around and around. So not quite right that time. So let's stop the code and we shall try it again. Okay. let's see, what can we do here? So we're going to go forward, get to the Dalek. Okay, so the Dalek, it gets to there. Dalek has to move. So I think the first part of my code is correct. The issue is with the second if statement. But then again, I still could be wrong, so we'll just keep trying. I can see that more GIFs are being posted now, and we have quite a mixture, different GIFs. Okay. So, we've got our Dalek. Dalek's moving back. Okay. Okay. Seems to... I'm not quite sure what to say about what's currently going on with all of these GIFs. I'm just going to let it slide while I try and figure out what on earth is happening with this Dalek. So, Dalek moves back. If the Dalek is then... The problem is when he gets to here, we've got to still try and turn. And that's where the problems are. So when the Dalek gets to here, it's got to turn. Yeah, let's just not ask questions. The best approach. Okay, where was I? So Dalek moves back. We've then got to figure out what's going to happen here with the turn. So, instead of the Dalek moving right, how about the Dalek turns to the right? And then, if there's a wall, we'll have the Dalek turn left. Oh, I can see that Alex has completed it. Well done. Fantastic. So, is that your high score that I can see on there? Let's have a look. Both finished, well done. Ah, so that's the time, so 27:06. Fantastic. Okay, well done. So, fantastic. So, since if the two of you have finished, which is really well done, you did it in 25, fantastic, okay. So, how about have a go at running through that again. So before we move on to the next activity for the day, how about having a look to see now, if you can, you can see that I have an issue with my Dalek here, it's stuck. Have a look at see if you can now do that in Python. Okay, so since we're moving on to Python in a little while, say in around 5-10 minutes, have a look to see if you can start working your way through the same activities, but doing it in Python, and see how you get on, because we're going to be looking at Python in a second. Have any of you used Python before, by any chance, just out of curiosity? Have you sort of delved into using it, or you've used Python before for this? Okay, that's pretty good. So what we're going to be doing is essentially, you did it entirely in JavaScript and Python. Oh, lovely. Oh, yeah, I can see that now. Sorry, Alex. Oh, fantastic. Which did you find easiest then? Was it the JavaScript or the Python? And you've never done Python before today. Okay, that's fine. So don't worry, because we're going to be going through it. What we're going to be essentially doing is applying what concepts we've used in this with Doctor Who today. Definitely the JavaScript. Okay, interesting. So what we're going to be essentially doing is applying the concepts that we've done in Doctor Who's microbit programming today to in make code, so that we can essentially try and see how the two of them kind of tie in together type thing. And then once we've all been through that, the last part of today's session will be completely sort of free time. So you can program any other games that you like and things like that. But we'll go through the microbit Python stuff first, and then we'll have a bit of free time at the end, okay? So I'm still stuck. So at the moment I am turning right and I am getting stuck. So this is not going well. So Dalek gets to wall. So we are not going too well here today. Put the Dalek first. Okay. Oh, I see. Okay, I see your point. So I shall try that. Feel free to send tips. So put Dalek first. I see what you mean. Okay. You only need to change the bottom blocks. Okay. So we can see that what we're getting here are different solutions from different. So as you can see, this kind of reinforces what I was saying earlier about this idea of there are different ways of going about it. So, okay. Okay, in that case then, what we'll do, we'll leave it as like that. And we'll have him, so we'll keep that one the same as it was a second ago. So I'll change the bottom blocks around. Okay. So we're getting to a wall turning right, and then we are let's have a go. So forward, 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 turn right. So obviously that's not correct. So we've tried turn right, we've tried move right. So different solutions. So obviously there's a problem with my code. So what I would like, when the second door closes, where's your Dalek going to end up facing? Okay. So what I would like, so since I'm stuck, let's make this part about you teaching me, okay? So you tell me what I need to do. So I can see here, Alex is saying you only need to change the bottom blocks, okay? And when the second door closes, where is your Dalek going to end up facing? So currently, my Dalek is going forwards. The Dalek is turning right, and if there's a wall, okay, so obviously that's wrong. So let's just say the Dalek is currently moving to the right, and if there's a wall, the Dalek is turning left. So that's obviously not going to work. So at the moment, if we run the code, because remember, one thing is keep testing the code as you're working through it. So obviously this isn't going to work. So currently, moving right, going left, no good, okay? Because he's just going to end up going backwards in the complete wrong direction. So we're going to move to the right. So that's obviously not. So door closes, he turns right, moves to the right, and if there's a wall, currently, if he turns to the right, he's just going to end up getting stuck again. So what can I do here to fix the problem? He's going. Gets stuck. Stuck again. Going the wrong way. What can I do here? Who wants to give a hint? So obviously the issue is with this else statement down here, isn't it? Use turn around instead of move left. Okay. So that's one suggestion. The funny thing is that I solved this the other day. That's less of a hint and more of an answer. Fair enough. So what are we saying? That the second if statement needs to be a turnaround? Let's try it. Now, so we're sort of almost we're getting there. So we're moving right, and of course, like you said, Chris, instead of move left, we want to be turning around. Anybody else off? So, see, Alex is typing. Move right isn't required. Okay. So we don't need to move to the right. So turn around. But you can make it work with it. Okay. So are we going to turn around? So if there's no Dalek, it's going to turn around. Okay. I see. Okay. So what we'll do, for the sake of moving on, okay, is I am going to, just because we need to move on and things like that, so that we can have enough time to cover everything, I'm going to have it complete the solution for me, okay? So, as you can see, there is the solution. So I can see that it's saying, Chris, as you suggested earlier, it sends the Dalek, you know, the voice part, that comes first, okay? And then you can see that it, if it's empty, moves forward, okay, as we said. And then if it's not empty, it turns to the right, but if there's a wall, it turns around. Okay, so well done. Okay, that was pretty good. But what we got from that, as you know, is that there are different ways of going about doing things. So first was putting, for an example, the Dalek talking first. I believe, Alex, were you doing it in a different place? Okay, so essentially the idea is that there are lots and lots of different ways in which you can do it. There are basically tons and tons of different solutions. So, well done, okay. I knew that you would all be way better than me at that. So what we're going to do now is we're going to move on to actually looking more at make code, and we're going to start programming our virtual microbit. Okay, so if you haven't already navigated to the site, I'll pop a link in the Discord. There we go. So what we're going to be doing is we're going to be programming a virtual microbit to play. Well, this is where it comes up to you. Okay, so we're going to be programming the microbit to do a rock, paper, scissors game. Okay, however, if you wanted, you don't necessarily have to do it as rock, paper, scissors. You could do it as anything that you want. Okay, any sort of shapes, symbols. Okay, you could try and tie it into Doctor Who if you wanted to. You can tie it into whatever you want to. Okay, but the idea is that we're going to be programming the microbit using some Python, okay, to play the rock, paper, scissors game. Now, like I said, it is completely up to you what shapes, what symbols you go for, okay. There are lots and lots of different tutorials. However, we're going to be just starting a new blank project, and we're going to be working through it together, okay, just so that we can see how those different concepts all tie together, how everything fits. And then, but how you design it and how you go about, you know, as I should say, what sort of symbols and things like that you choose to have as your rock, paper, scissors equivalent is entirely up to you. So if you all navigate over to makecode.microbit.org, and then what we're going to do is we're going to click on a new project, okay? So I'm just going to call mine, so we'll just call it game test, okay? You can see that there are code options. You can choose what language that you like. I would recommend that you leave it on blocks, JavaScript and Python, just because you can then see the differences between each language as you cycle through them, I believe. So if you leave it as blocks, JavaScript and Python, I think you should be able to see how they all compare as you click through them. So we're going to leave it as blocks, JavaScript and Python. We're going to go to create. And what you might see is that make code is, of course, very, very similar to the code builder that we've used in Minecraft. Okay, so of course in Minecraft we were using the code builder to do different sort of programming our agent to do different things. So the same principle sort of applies, the same platform in a way is used here for microbit. So like I said, what we're going to do is we're going to be programming our microbit, and if you have a microbit at home, feel free to plug it in and download, I think it's the hex file I think you use, and upload it onto your microbit, take pictures and put them on the Discord if you like. But if you don't have your own microbit at home, don't worry, because you don't need one. Okay, this activity is based solely around the idea of us all using a virtual microbit. So as you can see, we've got our microbit up, and it by default loads us into the block-based programming. But what I'd like you to do is select Python, and so we're going to move across to using Python. I apologise, by the way, if it is very slow on my screen. My MacBook doesn't really enjoy streaming as well as doing other things. If you've got yours for this, that's fab. Go and grab it, and we'll definitely upload it onto here. I'll wait for you to come. I'll give everybody a few minutes before we carry on. You've got yours too, Alex. Fab. Oh, that's fantastic. Oh, I'm really pleased that you've got some, because I wasn't, like I said, I've planned this session around us using virtual microbits, but I wasn't sure if any of you have got any at home. Fab. Okay. I did once have a microbit, but I borrowed it from somebody, so I had to give it back, unfortunately. But I used to have a microbit, and I thought I was really surprised at how much you could do on a microbit. There's so many different things that you can do. I thought it was fantastic. So you can see that Alex and Tish, you've both got yours now. Fantastic. So I'll just leave. Just give it just a minute or so, just for everybody to get loaded up onto make code, and then we'll get started then. That's all right, Hiz. You go. You get what you need to. Go and pick up what you need, and then we'll, like I said, we'll make a start in a second. Don't rush. We have plenty of time, so no need to rush. Okay. Cool. Okay, so we'll get started then. So feel free, so Python, when you load up the microbit Python section, it will probably give you, because in the block section you might have noticed that there's actually a forever and an on start block already placed in there. So as a result of that, when you click over onto the Python side of things, it does give you, it by default loads in some functions for you already. Okay, so you can just delete all of that to start with. Okay, that can be the first thing to do. Just delete everything, so you've only got the one line. So we're going to start completely from fresh. Okay, So what I'm going to do is, like I said, I'll talk you through it step by step. And then if you have any questions, if there's anything you're not sure about, just tell me and we'll go through it, okay? There's no rush. Just everybody take the time and we'll work through it together, okay? So Python, you will find, as we're working through this activity, has a lot of very similar concepts to what we've seen with the block-based programming, okay? So the way that things are worded are very, very similar to the way that it's done in block-based programming, okay? Or even if you've dabbled with JavaScript, you'll find that there's actually a lot of stuff in JavaScript that's already done as well. That's very similar as well, okay? So a lot of these concepts overlap between programming languages, which is why it's already really, really good that some of you have, that you're already really good at block-based programming, that some of you have used JavaScript and things like that. It's good because a lot of these concepts, you will see them across multiple languages. So Python is a nice language to learn because it's a very high-level language. So we have these different languages, okay? So high-level languages are those that are very close to kind of English. So a lot of the words and things that you use are essentially sort of like English, okay? And then you have a lot of sort of low-level languages, and these are closer to things like machine code and that sort of thing, okay? So what we're going to do, we're going to work through this building up our own sort of version of rock, paper, scissors using the microbit, okay? So the first thing that we need to do is we need to declare a variable, and we all know that a variable is a slot of memory, okay? It's like you can picture it like a box, okay? Like a box. So it's a slot of memory that's going to hold a value, okay? And we can use that value then throughout our program. So what you call your variable is entirely up to you. It doesn't matter what you call it, but just remember it needs to be given a meaningful name. So what I mean by that is that it needs to be something that you can remember what it is, okay? So for the purposes of this activity, I'm going to call mine hand, because of course in rock, paper, scissors you use your hand to demonstrate rock, paper, or scissors. So I'm going to call my variable hand, so it's going to be called hand, and we need to give our variable a value. So I'm going to give it a value of 0, and you will see why in a minute. So I'm going to put equals 0. I'll see if I can zoom in for you actually, just in case it's a bit small. Okay, it's probably a bit big. There we go. So I give my variable called hand a value of 0. Now, one thing that we've talked about in the past is this idea of a function. Now, of course, a function, okay, is a piece of code that can be used over and over and over again within a program, okay? So when you have a function, you can put loads and loads of lines of code into it, but that will mean that if you say need to run that bit of code in another part of your program, you don't then have to rewrite all of that code out again. You just simply call the function up. Okay, so instead of us having lines and lines and lines of code, and then further on in our program we go, oh, I need to do that again. Instead of you having to write all of that code out again, or try and copy and paste it, and then miss things, etc., etc., you can just simply call the function, and then all of that code will get repeated. Now, in Python, we can define a function using a keyword known as dev. Okay, and you can see that when you call, ignore the fact that it says there are loads of problems, by the way. When you call a function up, you get given, it changes keywords, a lot of keywords in Python change color, so that way you know that you've got the sort of the correct word spelt out. So you can see that with my variable, once I've defined the value, it's turned green. When I've typed out the word dev, it's changed it to blue. Okay, so that it color, in a way, it kind of color codes different things. So what I've got is the keyword dev, okay, and that's essentially us defining our function. Now, what we need to do is, what you would ordinarily do at this stage is you would then give your function a name, so that way when you call the function, you would call it using its name. But with microbit, we need to say what happens to the microbit to make it run the program. Okay, so microbit makecode will suggest things for you, and the one that we want is on gesture. Okay, so we want on underscore gesture, and we want the gesture to be shake. Okay, so microbit, dev space on underscore gesture underscore shake, and then we need an open and close bracket, okay, followed by a colon. So what this line of code is saying so far, okay, is dev, okay, so dev meaning define, okay, so we're defining our function, and then we're saying that when the microbit is shaken, we would like it to run some code. So if you were just programming in Python ordinarily, you would, after the word dev, you would put the name of your function. But when you're programming a microbit, you need to tell it what it's doing or what it needs to do in order to run your program. So dev on gesture shake, okay, open and close bracket, and that open and close bracket is there to pass, if you needed to pass a value in. Now you don't need to do that or worry about that here, but in some programs you need to pass in a parameter in order to run the program, okay, in order to run the function. So you might need to pass in a number or a word or something like that, and that would then run the function for you, okay, but you don't need to worry about that here. The purpose of the colon, okay, so the two dots, is to say everything that comes after that colon we then need to have included as part of our function, okay. So I'm going to press enter, and what you will see is that by default, okay, make code will indent our code, okay, which means it leaves a gap. And the reason that we've got that gap there is because Python is quite particular about the way that we indent our code. So everything that's indented, okay, so you could say tabbed, okay, so you can see if I press backspace and then I press tab on my keyboard, it moves the line back in. Everything that's indented is now part of our function, okay? So the idea is that we need to make sure that anything that's included as part of our function or anything that's included as part of an if statement, as you'll see in a second, is indented so that we can keep track of what goes where. Okay, so you'll see more about what I mean about this as we work our way through the program. Has anybody got any questions so far? Is everybody okay? I know this is new to some of you, this idea of using Python. So if anybody has any questions, remember to just, or if I'm going too quickly, just pop the message up in Discord, okay? And I'll slow down. Alex is all good, lovely. So yeah, if anybody does have any questions, or if anybody thinks I'm going too fast, just tell me, and I'll slow down, okay? Okay. So next thing that we need to do is make our variable a global variable, okay, which means that we can use it throughout our function. So I'm going to use the word global, and then I'm going to name our variable. So of course our variable is called hand, okay, and I'm making that a global variable, so it's going to be global hand, okay. So as we know, there are different types of variables: local variables and global variables. And local variables are ones that are sort of confined to. So let's cast our, if we think back to when we were doing Game Fruit, which seems like ages ago now. When we were programming on Game Fruit, you might remember that we were making up variables, and the variables that we were making, some of them were local variables, which meant that they were defined to the one script. but some of them were global variables, which meant that we could use them throughout any script in the program. For an example, when we were programming those keys to unlock the doors. So when we were programming the keys to unlock the doors, we had a variable that we needed throughout the program. So that way we could program the key variable onto the key object. We needed it, I believe, on the door object, and we needed it on the playable character, if I remember correctly. And therefore, what we were doing there was we had a set of variables, the same variables, sorry, but used across multiple different scripts. Okay? So we've made our hand variable a global variable. So we now need to, as you can see, we've given our hand variable a value of 0, but we need that value to change when our microbit is shaken, so that way we are able to I paired my microbit to the computer so I don't have to download the file every time. Perfect, yeah, good. So what we need to do is we need to change the value now of our hand variable so that every time the microbit is shaken, the value of the hand variable changes, okay? And Python has this really useful randomizer, I guess you could call it, okay, which changes the value of your variable to a different random number every time the program is run. So we're saying hand, okay, is equal to, so our hand variable is equal to something called randint, okay. So randint is saying that we're going to be programming our hand variable to have a different random number every single time the program is run, okay? And by int, it means integer, which means a whole number. That's it, Alex, yeah, spot on. So random integer, lovely. So we're saying a random integer, and we have to say between two values. Now, of course, that's what goes inside of these brackets. So a random integer, okay, obviously in a rock, paper, scissors game, it would be one of three potential options, wouldn't it? It would either be rock, paper, or scissors, which means we've got three values there. So you could either say between 1 and 3, or you could say between, say, 0 and 2, for an example. Okay, I think between 0 and 2 would also work in this case. But you could say every time the microbit shakes, we'll be generating a random integer between 1 and 3. Okay, so make sure that you've got that comma there as well, by the way. Okay, so that way it knows that it's between 1 and 3. And an integer is a whole number. Okay, so an integer can be any number that doesn't have a decimal place. If you have a decimal place in your number, so say you had, say, 1.2 for an example, that could be known as something as a float. Okay, so a float would mean that you've not got a whole number, but you have something that's got a decimal place. Okay, so you've got integers and you've got floats. So that's two examples of programs. So say randint doesn't work with in this case with floats, okay, because obviously it's for an integer, okay. But if you wanted to program a float when you're doing Python, so if you needed to deal with numbers that weren't whole, you could say that it's a float, okay, rather than an integer. So far, what we've got here, if we just run through these first 5 lines, we have got our hand variable declared and initialized to hold the value of 0. We've then got our function, which is defined by the keyword dev, and we're saying that our function is going to run when the microbit shakes. Okay, so every time we shake our microbit. We've then made our hand variable a global variable, and we've defined it, the random that we've defined it now as saying every time the variable, the microbit shakes, it's going to be given a different value of between 1 and 3. Okay, so that's where we're up to so far. If anybody has any questions, feel free to post them in Discord, okay? But the next part of the program is we now need to say what happens when the microbit lands on a certain number, okay? So is it going to be a rock, paper, or scissors? So to do this, can anybody think of how we can do this to start off with? Has anybody got any ideas of what if we need to do something? Yeah, Trace has got it spot on, so an if-else. So we're going to be using an if-else. Now, in Python, if statements and else-ifs and else statements are all something that you can do. Okay, so we've got if statements and else-if statements and else statements. So we're going to be using those today. So we're going to move down one line onto line 6. Okay, and we're going to use the keyword if. So we've got an if, and we need to say if our hand variable is equal to 1. Okay, so if it reaches, so if the microbit gets shaken and the hand variable lands on 1, okay, what do we need to do? Well, we need another colon to start off with, because you'll see now that if we add that colon to the end, yes, well, nearly to this. So you could say print, okay. So if you were programming this, say, on a computer, and you were saying every time the program is run, we need to print the word rock, paper, or scissors, you could definitely do it. But what, of course, we need to do in the case of a microbit is have it show LEDs, okay? You could have it print out as a string if you wanted to, but what I'm going to do on here is I'm going to say show LEDs to show a symbol. So good question from Alex. Are there meant to be two equal symbols? Yes. So I'll explain that. So it might sound confusing. So if you don't understand what I'm explaining, then let me know. When you were giving something a value, so you can see that here we've got our hand is equal to 0. So this one equal symbol means that we are saying that the hand variable is being given the value of 0. Okay, so we're giving it 0. Same thing here with when we're giving it the values of a random integer between 1 and 3. Okay, you're saying the hand is going to be given the value of between 1 and 3. Okay, dependent on what the computer decides. The reason that we have two equal symbols here is we're saying if the hand variable comes out as 1, okay? So we're not giving the hand variable the value of 1. We're saying that if its value is 1, what do we want it to do? Okay, so instead of us giving the hand variable the value of 1, we're saying if the hand variable turns out to be equal to 1, what do we want it to do? So the double equal sign essentially means if it's equal to, and the single equal sign means that we are assigning it a value of something. Okay, so I hope that makes sense. There are two different, so you can have equals once or you can have double equals, so equals once means that you're giving something a value, and double equals is checking to see if a value is, if it is equal to something. Okay, I know it sounds quite confusing, but if I'm not being too clear on what I mean by that, I'll try and go through it again for you. What you'll note, though, is after we've placed this new colon, okay, at the end of this if statement line, we've now indented again. So you can see that we've now gone, if I go back, we are now 2 tab lines in rather than 1. So what we're saying now is we're still part of the function, but these next lines of code are going to be part of the if statement, okay? So as you can see in Python, it's very, very specific about where you line things up. Okay, that's the only thing really that Python is quite sort of specific about, is how you indent your code. And so, for an example, if you were indenting your code with 1 tab to start off with, so here we've indented everything that's part of our function has been indented with 1 tab space. Okay. If you were to start off your code with 2 tab spaces, you would then need to keep that consistent throughout your code. Okay, you can't swap and choose how many tabs you indent your code with. You have to keep it consistent. It's the only thing that Python is picky about. So we're saying if our hand variable comes out as having the value of 1, what do we want to do? Well, what I'm going to do, you can do it differently if you want to, but I'm going to have it show the LEDs. So I'm saying basic.show underscore LEDs, okay? And you can see now that what pings up is a layout of the LED lights defined using hash symbols on and dots, okay? You can see that we've got 3 speech marks, okay, to open and close the sort of show LEDs. And what I'm going to do is I'm going to tell my microbit that I want it to show the LEDs that are in the shape of a rock, a paper, or scissors. So I'll start off with rock. Okay, so to program the microbit to show the rock, I'm just going to go like this. So hash, and then we want that one as a hash. So getting rid of each dot that we don't need. And then I'm going to go down one again and do that like this. There we are. So what I've got there is my rock. Okay, so I have told the microbit's LEDs to show a picture of a rock if the value of hand is set to 1 after randint runs when the microbit is shaken. So every time our microbit is shaken, the value of hand is going to change because of that randint. Okay, and if it comes out as being 1, it means that we want our microbit to display a rock. Okay, now this is similar in concept. The same principle now needs to be applied if we want the hand, if hand variable comes out as 2 or if hand variable comes out as 3. Okay, now this is going to seem strange. However, since we are now out of the if statement, we need to make sure that we go backwards in tab so that we are in line with the word if, okay? Because the else if is not going to be part of the if statement, okay? The else if is going to be separate, but still part of the same function. So you need to come out of the if statement. We've now finished with the if, and we're moving on to the else if, and the else if needs to be in line with the if statement. And an else if in Python is defined as elif. Okay, so it's spelled like that. Elif. Okay, so elif means else if, and you can see that I've aligned that with the word if. Okay, so I'm saying elif hand is equal to 2, and then we're going into the elif. So we're going back into that double tab. Okay, so we've moved away now from single tab back into double tab. So if my hand variable is equal to 2, I want it to show the LEDs of paper. So we'll go basic.show LEDs again. There you go. And I want it to show a picture of, or diagram of paper. So I'm just going to do it like this. Again, what symbols, what you design is up to you. It doesn't have to necessarily be rock, paper, scissors. It can be anything. Okay, I'm just going with the sort of normal game here. But I'm going to do it like this. So there's my paper. Okay, so that's my paper. So now we're saying if the variable hand is given the value of 1, then we want it to show rock using the LEDs. If it comes out as 2, we want it to show paper. Okay, so that's what we're up to with that so far. Now, when we move on to doing scissors, in a way the choice is yours. Okay, as to how you do the next part. You can either do another elif, so that you're saying hand if elif hand is equal to 3, show scissors. However, since there is only one more option, okay, since there is now only one more option, which is of course the number 3, you could just say else, okay, because now what we're essentially saying is by saying else, we're saying if the value hand is given any other value other than 1 or 2, then display scissors, okay? But if you wanted to program the microbit to display scissors if it was a just a 3, so if it was scissors can only be displayed if the value is 3, then you can say elif hand is equal to 3. So I'm going to go with that option. Okay, I'm going to say elif hand equal to 3, colon. So again, making sure that the elif is in line with the if and the elif before it, colon, back to the indented code, basic.showLEDs, and this time I'm going to do some scissors. Okay, there we've got scissors there. So let's get these scissors done. Now, something to point out actually is, of course, this idea of comments. Now, we've discussed comments before. As we know, the purpose of a comment is that you use it to so the purpose of comments is that you use them to remind you in a way of what a bit of code does. Okay, so say you're writing lots and lots of many lines of code, okay, and you kind of go, oh, what's that bit of code doing? What's the point of that bit of code? What you can do is, what's the point of that line and things like that? You can write comments so that you can remember what each thing does. Now, in Python, a comment is defined using the hash symbol like we've been using here. Okay, so if you said comment, this is a comment. I'm not quite sure if the same principle applies in make code, but if you were coding in Python, okay, using idle or something like that, the hash symbol defines a comment. So you'd be saying this is a comment, and it would disregard that line when it was running. The computer would completely ignore that line when it's running that bit of code. Okay, so it would just completely ignore it. But comments are really important so that you can remind yourself as to how a bit of code works in case you're not too sure. Sort of when you're looking back on the program after maybe not looking at it for some time. So that's now all of our if statements. We do need to just finish up the code, okay, with one final line, which basically tells the microbit again, when this bit of code is run, we want to run the onGestureShake function. So we're saying input dot on underscore gesture, and then we're saying open bracket, and we're saying gesture dot shake comma underscore gesture underscore shake. Okay, so what essentially this bit of code is doing here is it's saying that once our microbit gets shaken, okay, we would like it to run our function essentially. Okay, this is what I mentioned earlier about this idea of once you've built a function, okay, you then need to call the function. So once you've written out your function to do all of your different things, you then need to call the function at the end so that the computer knows that it needs to run it. And sometimes you will need to pop some parameters into the function to make it work. You don't need to do that here, but sometimes you will need to pass parameters, but you don't need to worry about those. So this should now be my completed code, but I'll give it a run through. Okay, make code isn't reporting any problems with the code, but that's not to say that there aren't any. Okay, sometimes you can find that you have errors in your code, There are lots and lots of different types of errors. You can have syntax errors, which are basically like typos in a way, where you've forgotten something or you've misspelt something and it's caused some confusion. You've got runtime errors, which are errors that can occur when the program is being run. So there might not necessarily be a problem with the code when you've written it, but when you are running it, you find that the outcome isn't quite what you anticipated it would be. Okay, so that's an example there of a runtime error. But if I run through the code quickly with you now, and then we'll see if it works. So, defined my hand variable. Okay, so I've got a variable, I've called it hand, and I've defined it and initialized it with the value 0. Okay, so that is now my hand variable and it has the value of 0. I've then defined my function, which is defined by the keyword dev, and I'm giving this function the ability to run when the microbit is shaken. Okay. Then have the colon that comes at the end, which states that this is now the start of my function. We've then made the hand variable global so that we can use it throughout the program, and we have then told the program that when the function is run, it then needs to be given a value of between 1 and 3, which we have defined using randint. Okay, so returns a pseudo-random number between min and max included. If both numbers are integral, the result is integral. So essentially, we're saying here that between 1, if the when the program is run and the function is called, the hand variable will be given a value between 1 and 3. Yes, it is. I can indeed. Let me zoom out and scroll down for you. There you go. Hopefully you can see that. I'll scroll down to where we're up to with the code. There you go. So we're saying if the hand variable is equal to, when the program is run, the hand variable will be given a value of between 1 and 3, and that is defined using the single equal sign. Okay. Then we jump into the if statements. So every time, of course, our program is run, our hand variable will be given a different value. That doesn't necessarily mean it won't be the same as the previous one. So you might run it and you'll find that you've got 1 comes up every time, maybe for 5 times. Then it will do 2, 3. It's random each time. Okay. So we're saying if our hand variable turns out to be the number 1, then we want it to show a rock. Okay, using the LEDs. Again, you could have. It's up to you how you did that. You could have maybe even had it done as a print statement so that it said the word rock. Okay. If else if, which is defined by the keyword elif, the hand variable is equal to, turns out as being number 2. We want it to show the symbol for paper. Okay, or again, print the word paper. Elif, okay, the hand variable turns out as number 3. Then we want it to show scissors using the LEDs, or again, you could have it printed. And then finally, we're saying input.onGesture, gesture.shake, onGestureShake. Essentially, we're saying there, if the microbit is shaken, we want it to run our function so that it displays a different symbol each time the code is run. Okay? And that should be how we play the rock, paper, scissors game. And we will now test this using my virtual microbit, which I have here. So if I hit play, it's probably going to be quite laggy because of my my Mac struggles with streaming. But if I hit shake, hopefully this works. You can see I've got scissors. If I shake again, I've got paper. Shake again, it's gone back to scissors. Shake again. Got a rock this time. Paper, rock. Try again. Paper, rock. Okay. There's paper again. There's scissors. So you can see that what the code is doing there is that it's choosing a different random integer each time between 1 and 3, and it's using that as a means of determining what symbol to display. Now, if we wanted to add further options. So let's just say, for an example, we said rock, paper, scissors. I don't know, what could we use as a third example? Rock, paper, scissors. What could we do? On the spot thinking, not good. Rock, paper, scissors, pencil. Okay. What we can do is we can increase our random integers range. So we could say now between 1 and 4. And then we just simply need to add another else if hand is equal to 4 basic dot show LEDs, and then we can do a pencil. So I could just do a very, very simple pencil. And it's just going to be I'm just going to define it with a single line. Okay, I know it's not a very good example of a pencil, but that's a pencil. So rock, paper, scissors, pencil. I've added another else if statement. Okay, and you can see now if I run the code again, there's my microbit. Scissors, paper, scissors, pencil, rock, pencil, paper, scissors. Okay, so you can see that every time the program is run, it's now choosing a random integer between 1 and 4. Okay, so that is a bit of in a way, a bit of a crash course into the fundamental coding concepts of Python. Okay, there are lots and lots of different things you can learn with Python, but what you can see is that it is very, very similar in concept to what we did before with Dalek Hack, and what you've probably done before with block-based, or if some of you have used JavaScript, similar to JavaScript. Okay, different coding concepts there, but all really following the same pattern. Okay, so hopefully you all found that okay. Does anybody have any questions? You added a clear and shake button, Chris. That's fantastic. Yeah, so brilliant. Again, you can tinker with this program as much as you want to. Okay, it's entirely up to you. You could even, there's so much more that you could add with you and Tris and Alex having actual physical microbits. There's so much more functionality that you can add to this program, because of course you could do things if you wanted to with the sensors, with the I know I could also do things with the buttons, but with my laggy Mac, it's probably not perfect. But you could do things with the buttons. You could do things with the sensors. You could do anything. Okay, Microbit has, of course, as you know, so many different options of what you can do with it. However, what did you all think of Python so far? Did you find it okay? Did you find it confusing? Was there anything that you weren't sure about? I know it's a little bit... This is something that I've been doing, that I learnt, okay? So learning how to program using Python, not exactly with a microbit, but learning how to program with Python is something that I was doing as part of my degree. So what you've just done today is something that I've learned as part of my degree. So I think if you've got your heads around this, which I'm sure you all do, that's really, really good work, because I've been learning this stuff now, and you're learning it much earlier than what I was, which is really, really good going. So if you figured this out, you should all be proud of yourself. So you're playing on the simulator and the microbit. That's pretty good. So you can play against each other. That's a really good idea. So well done to everybody for doing that. Feel free to post some pictures on the chat if you want to show us what you've been up to and how it's kind of tied into your own microbit. So we've got 25 minutes left before 6 o'clock. So the plan for the rest of today's session is to basically do whatever that you sort of want to do. Okay, if you would like to, so I'll just go back to the microbit homepage. So you can see that there are loads of different tutorials. With some of you having actual physical microbits, this might make it easier because there are more choices of the things that you can do. But as you can see, MakeCode have got lots and lots and lots and lots of different microbits that you can do. And because some of you have got actual microbits, like you're doing, Chris, you can play on the simulator and the actual physical microbit so that you can do that idea of having like a multiplayer game in a way. But MakeCode has got lots of different tutorials. They've got, as you can see, different toys that you can build. You can do different sort of sciencey stuff. You can use different tools. Okay, loads and loads of different stuff. And there's even Alex. There's stuff here for JavaScript as well, and how you can program your microbit using JavaScript. If you wanted to take a look at those. I'll just take a look actually, see if it actually does work. I'm hoping that my code appears between the two languages. Let's have a look. Hopefully this works. It's very, very slow. There we are. So you can see, if you switch back to blocks, you can actually see here the different blocks and the way that in which it's been programmed, but using block-based programming, and you can see how it's very, very similar to what we've done in Python. It might look like a lot less using the blocks, okay, but it's exactly the same principle, okay, just instead of blocks, we're using a bit more words. If we flick over to JavaScript, you can see again, it's very, very similar, okay. We've got function, okay, we've got our hand variable using randint. We are saying what happens when we are, if the hand variable is equal to 1, else if what happens if it's 2, 3, and 4, okay. So there's 37 lines of code in JavaScript, and in Python we might have a little bit more actually. We've got 38, so not that much more, and that's only because there's a gap here. So same lines of code between the two, but you can see that the concepts are very similar in principle. Okay, between the languages, we're using if statements, we're using variables, we're using else ifs. You can see here that else if is actually in JavaScript defined as the word else if. Okay, rather than elif like it is in Python. Okay, you've got 75 lines in Python, Chris. Okay, so have you added some different stuff to your code? Feel free to, if you want to put a screenshot up of your code, feel free if you want to show us what you've been doing. Let's click back onto Python. There we go. So lots and lots of different things that we can do there. Okay, lots and lots of different things. So for the rest of the session, for the last 20 minutes, the choice is yours, really, okay, as to what you would like to do. So it's entirely up to you what you would like to do for the rest of the session. If there's anything that you want me to go through again or explain, if there's anything that you would like to do, let me know. Remember to keep sending in suggestions as well of potential activities you'd like us to look at for the upcoming coding clubs as well. Just post them in the general chat. Like I said, my Discord is normally always on, so I'll see them come up. So even if I don't reply, I've probably seen them. Okay. So just post them in the general channel on the TechnoCamp server, and I'll make a note of them so that we can get planning. Like I said, there's no guarantee that we'll be able to do everything. And of course, we've got to bear in mind that different people have got different hardware capabilities, so we have to kind of make sure that it works for everybody. However, we will try and our best to ensure that we can cover as much as we can. Okay. Yeah, I think we've all been there for this. When you delete a block of code that you thought was useless. Yeah, I think we've all been there with that. Has anybody out of interest done anything more with Minecraft at all recently? Doesn't necessarily have to be on Minecraft education. been doing some building. That's pretty cool. Your I remember it's your observatory that you built. I think it was an observatory, right? During the last when we were doing Minecraft, was absolutely amazing. Really outstanding. Okay, that's pretty cool, Alex. Yeah, server with friends. No, that's pretty cool. A massive replica of a tiny Minecraft room. Okay, that's interesting. I'm actually, at the moment, I'm in the process of building a... Yeah, send a picture first whenever you can. That'd be quite interesting to see. I'm in the process of building a replica, a not-to-scale replica, I should say, of Carnarvon Airport up in North Wales for STEM ambassadors, who I also work with. We're like doing a bit of a session on different sort of coding things and that, and so I'm in the process of building a Minecraft Carnarvon Airport, which is going well so far. I've not finished it yet; it's taken quite a bit of time, but it's going well so far. So that's what I'm currently up to on Minecraft. But I haven't actually got a server with friends or anything at the moment, but it's definitely something I think a lot of my friends and I are looking into doing, hopefully. What? What's that then, Tris? Oh, right, okay, so it's a server on Minecraft. Oh, right, okay. I will definitely take a look into that. Loads of mini games. Oh, nice. Okay, that's pretty cool. That's pretty cool. So, oh, right, okay, nice, nice. I have to say, I appreciated all of the tips that all of you gave me when I was playing Minecraft. Certainly, certainly have been very useful. Definitely have been very, very useful. So thank you for those. I'm going to try and build another game following one of the following the tutorials. So I'll probably do a block-based tutorial here. For the 7 seconds game. So remember, there are loads of resources available on like Make Code and different things like that. If you want to kind of, try your hand at different things and sort of keep yourselves sort of like refreshed and things like that on Python, JavaScript, block-based programming and stuff. Loads of stuff online. If sort of outside of the TechnoClub sessions, if you wanted to do things, remember that we are. If you do need help with anything, just post some questions in the Discord chat. Sort of even if outside of the TechnoClub sessions, and we'll always do our best to reply as quickly as we can to help you out. You can see if you're making a city. That's pretty cool. Or is it a village? Either way, it's still a mix. Okay. Oh, a city/village. Okay, that's pretty cool. That's definitely a lot more advanced than my Carnarvon Airport, I'll tell you that. That's pretty cool. That's pretty cool. Okay, so I am doing... So the player starts the timer by pressing button A, which is there. So we're going to say when button A is pressed. There we go. Next step. We need to remember the time when the button was pressed so that we can compute the elapsed time later on. So we can say add time. Oops. In a start variable. So we're going to make a new variable. So again, oh, let's have a look. Oh, nice. Okay, I can see this a small version of the big build. Nice. That looks pretty cool. Oh, that's really cool, actually. I like that. That's really amazing. So I take it, is that Minecraft, like ordinary Minecraft then, Chris, or is that sort of like Minecraft Education? Bedrock Edition. Oh, right, okay. So, start. There we go. So there we are. So if I could drag this in here, that would help. There we go. Show something on the screen so that the user knows that the timer has started. So we could say, use some show icon, put tick. There we go. Something like that. Oops, put it in the wrong place. Oh no. There we are. So the player stops the timer by pressing button B. So we need to do that. So we want to there we are, and then we want to compute the time as running time minus start time and store it in a new variable called elapsed. Okay. So these little tutorials are really good for just sort of keeping those concepts sort of fresh, things like that. So we want math. So minus. Oops. Oh. So we want running time minus. There we are. The start time. And then we want set elapsed to running time minus start time. Pop that one in there. Check that was correct. Yeah, all good. And then compute the score of the game as the absolute value of the difference of time elapsed. Is that your base, Alex? That's really quite incredible. That is amazing work. That is very, very cool. Still under construction, so there's still more to do. That's amazing. Fantastic. That's pretty fantastic, I have to say. Oops. So it was, yeah, absolute value of time elapsed fine is 7,000. I thought so. Oh, whoops. No. Oh. elapsed minus 7,000. Oops. I think I got that time, didn't I? There we are. So that's fine, and that will go into B. There we go. So now we're all good. Button A, B. And then can we display score? There we go. So, pretty far off. Okay. So, we'll pretty much, I think, tie things up there for today. From today's session, just as we're coming up to like the last couple of minutes now. I suppose we'll finish up there, or just before 6 o'clock for today. So I really hope you all enjoyed sort of today's session and things like that. Like I said, we'll be definitely giving some thought to continuing now with the coding clubs over the next few weeks, sort of going into September. Are you all, just so I can sort of, are you all, would you all like to sort of carry on with these coding clubs? I know with school starting up and things like that again, would you all like kind of to carry on with weekly sessions and things like that? Yeah, okay, nice, good, I'm glad. I'm glad. That's good. Oh, I'm really pleased for this, thank you. That's nice. Oh, and thanks, Alex, that's really lovely. Okay, thank you very much. So definitely be carrying on then. I know even though with school starting, we'll still be here. Like I said, we'll try our best to carry on with doing them weekly. Please feel free to post your suggestions as you have been in the chat. And like Joe's saying, if any of your friends, oh, okay, Alex, that's well, at least there's at least I suppose we are here to give you some tugech as well. Oh no, that's a shame. Well, at least you could get some tugech here. That's that is a shame that you didn't get anything without. But at least you could have some tugech here. So that's at least we were here to do it. But yeah, as Joe was saying, see if your friends want to join in. Tell them because we are here. So let us know and things like that. Definitely try and get as many of your friends here. Hopefully we can get some more people involved, which would be good. But like I said, just so since the summer is coming to an end now, and lockdown is being eased and everything, thank you very, very, very much for joining into to these sessions. We really appreciate the fact that you're giving your time to kind of participate and join in and things like that. So really, really grateful for all of your contribution and all of the tips and everything that you've been doing. You've all been really, really fantastic. So thank you all sort of very, very, very much for joining in with our sessions and things like that. So we'll 100% be carrying on with things. Like I said, feel free to post stuff in the chat throughout the week and stuff like that. And so thank you very, very much. And like I said, just see, as Joe was saying, see if you can get your friends on board and things like that. It would be great. But so if you are back before the next coding club, I hope you have a good first day back. Otherwise, If it's not, we'll speak to you again next week, and that'll, I suppose, be the last one before you head back to school. But hopefully you've all had a good summer, and thank you very much. So we'll tie things up, I think, for there. Joe, I will stop the stream now, and then if I could just talk to you briefly in Techno Team, that would be fab. I'll move over there now. Thank you very much for this. We'll speak to you again next week, and thank you again, Alex, for today, and thank you everybody who was on the stream, and I'll speak to you all next week. Have a good rest of your week. See you later.